Hi, I'm Rich with InsideHPC. We're here at ISC 14 in Leipzig, Germany, and we're at the Intel booth. We have something very special here. We're going to talk to the winners of the PRACE Award for 2014. We have Alexander and Sebastian. First of all, congratulations.
Thank you very much.
Yes.
Thank you.
You're welcome. You're welcome. So tell me about this work. What was the science about?
So it was basically the eruption of a volcano, right? And it was executed on one of the biggest machines on the world, so on the SuperMUC, which is I think currently placed 12 on the top 500 list. And we used all these 150,000 cores which are available there. And we got a sustained performance of more than 1 petaflop.
More than 1 petaflop. And what were you simulating about the volcano?
So the eruption basically, right? And how the waves are traveling through the mountain when you have this eruption.
Does this help you learn about safety and things about volcanoes? Is that the object?
Exactly, and it helps us to understand how we can have such seismic waves traveling through the soil, and then also in the long term do real earthquake simulation in order to protect our assets here.
Okay. And Sebastian, what was your role in this? Were you working on the algorithms, or what were you doing?
I was working more or less on the inputs, so we have a large mesh.
Yes.
We need to read this mesh into all of the cores, into memory, and it's not that easy to read a large file on hundreds of thousands of cores.
So Sebastian, I want to ask you about the code, right? I mean, you're associated with IPCC, the Intel Parallel Compute Center. This is all about code modernization, right? So was there a baseline code that you had to port to the many core?
Yes, basically. So the original code is like 10 or 15 years old already.
Yeah.
And now we are at the informatics department of the TU. We are trying to modernize it, vectorize it, and use all these advanced functions of a modern CPU to run it faster on modern supercomputers.
So I gotta say, when I thought about PRACE Award winners, I was expecting a couple of old guys. So you guys seem very young to be doing this groundbreaking science. Is there a lot of that going on at your schools?
Yes, so we always focus on high-performance computing in our group, right?
Yeah.
And for me, basically, it's the second PRACE Award in a row because we won the 2013 award on molecular dynamics, right? So we basically say, okay, you need to optimize the entire simulation pipeline. So you're working together also with older guys, right, from the geoscience department or from the supercomputing center, and we are the PhD students, right?
Yeah.
We did the works here, and
okay. Well, I want to ask you about the challenges of extreme scale, because did you develop it like on a small system and then work with it to get it to scale on this gigantic machine, the SuperMUC?
Yes.
Yeah.
So basically, we identified some bottlenecks, right, and then we removed these bottlenecks. And as we said, and also Sebastian was mentioned, it's not just about optimizing the compute part of the application. So you have to care about I/O, you have to care about initialization, right? Because the computing center wants that you utilize their machine for computing and not for reading files.
So what's the next step with this? Is it a bigger problem, a more fine mesh? What would be the next logical step from what you've achieved here?
So the next step basically is the bigger mesh, right? And then also thinking about how we can leverage accelerator technologies, basically like Xeon-Phi, right? Because as you see, we were computing for 3 hours for this simulation, and it was just a volcano, not a real earthquake. So a real earthquake has even higher computing demands. And so we need to think about using coprocessors together with the main processor to accelerate the simulation and then to solve a real big earthquake science problem.